Welcome to Spring LIB.
Okay, so we have a secondary chloroalkane, like so. And we are reacting it, or we could say it's undergoing solvolysis in methanol. So the things we want to look at then are what kind of reaction is going to happen. Note that we are in a polar protic solvent, and we have a secondary carbon with our leaving group. Okay, so secondary doesn't really rule out SN1, SN2, E1, or E2, right? But notice that we're doing solvolysis in methanol, which is a weak nucleophile, weak base. So at that point, we can pretty much rule out E2 and SN2. And then, based on our solvent being polar protic, that's going to favor SN1 over E1. So it's sort of a process of elimination deal here. So what we're talking about then is an SN1 reaction. So now we consider that the chlorine will leave. To generate the following carbocation. And if we consider things closely, we'll notice that this is a secondary carbocation neighboring a tertiary center. So the thing that we often see in that case is migration of this hydrogen, right, to give us the more stable tertiary carbocation intermediate. The effect of this will also be that this methyl group, which was previously a stereocenter, is now, it's a planar carbocation, and when our when our methanol then comes into attack, since it can attack either from the top or the bottom, we're going to get a racemic mixture of products. In which, following deprotonation, so I'll draw two little arrows here. I'm going to skip the deprotonation because we don't need the mechanism. We're going to have a methyl group and a methoxy. And this will be a racemic mixture. Although, due to the symmetry of this molecule down this point, this is in fact not even a stereocenter anymore. So in fact, it's not technically a racemic mixture because there is no stereocenter. But we have destroyed the stereocenter that was there, and so this is our final product.